Hello and welcome to Mr. Tompkins Ed Tech. In this video I'll identify the top 10 most likely topics you'll encounter on a calculated paper and run through some of the typical exam questions to help you prepare for that paper. There is a worksheet that goes with this video and I strongly recommend that you try the questions first yourself before watching. Thanks to Dawn Crichton from Spencer Academies Trust for pulling this worksheet together, by the way. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on, and more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. First up, we're going to have a look at factors and multiples. Question 1, write down all the factors of 12. Now, don't get mixed up between factors and multiples. Factors are numbers that divide into your number without leaving a remainder, and the multiples are the numbers in that numbers times table. So when looking at the factors of 12, we're looking at all the numbers, all the numbers that divide into 12 without leaving a remainder. I tend to write this down in a little table, and I write them down in factor pairs. So 1 and 12 go together because 1 times 12 is 12. Try 2, 2 goes into 12, yep, 2 times 6. Try 3, yep, 3 goes into 12, 3 and 4. Now you should, if you do it this way systematically, kind of meet yourself coming back down the other way, so then you know you haven't missed any out. So all the factors of 12 are going to be 1, 2, 3, 4, 6 and 12. Part 2a says write down all the factors of 18. So I'm going to do the same thing. I'm going to start with 18 at the top, and I'm going to start with 1. 1 times 18 is 18. 2, yeah, 2 goes into 18. 2 and 9. 3, yep, 3 goes into 18. 3 and 6. 4, no, 4 doesn't. 5, no, 5 doesn't. And I've kind of met myself down the coming down the other way because there aren't any more numbers between 3 and 6 to try. I've tried all of them and they're not factors, so I know I've got all of them. So again, factors of 18 are going to be 1, 2, 3, 6, 9 and 18. Part B says work out the lowest common multiple or LCM of 12 and 15. Now there are two techniques that are useful for working out LCMs. The first one is just to list all the multiples of a number until you reach one that they have in common. So if you think about 12, the multiples of 12 are going to be 12, 24, 36, 48 and 60, and for 15 it's going to be 15, 30, 45 and 60. Now after not too long you should find that you've got one the same in both lists, and then that is going to be our LCM. Okay, now with small numbers it's easiest just to do it this way, just kind of systematically go through all the multiples until you find one that's a pair. Question 3 says work out the highest common factor HCF of 12 and 18. Now again, when the numbers are small it's easiest just to do an exhaustive search. So you find all the factors of 12, we just did this a minute ago. So 1 and 12, 2 and 6, 3 and 4, and we find all the factors of 18. 18 has 1 and 18, 2 and 9, 3 and 6, and then we think, well, which ones do they have in common? Well, 1's in both lists, 2's in both lists, 3's in both lists, 6 is in both lists. Okay, you see they're all both in both lists, but the HCF is going to be the biggest one of those common factors. All of the other ones are common factors, but the largest one of them is the highest common factor, so the HCF here is equal to 6. 4a says work out the highest common factor HCF of 12 and 20. Again, these numbers are still quite small. I would just recommend listing out all the factors until you find the one that's common. So factor pairs of 12, 1 and 12, 2 and 6, 3 and 4. Factor pairs of 20. Well, 1 and 20. 2 goes into 20. Yep. 2 times 10 does 3. Nope. Does 4. Yes. 4 times 5. And I've met myself coming down the other way then. There's no numbers between 4 and 5. So I know I've got them all. So now we've got all the factors listed. I can see that we've got 1, 2 and 4 in common on both numbers. And so the highest common factor of those is going to be that 4 there then, isn't it? The 4. Okay, so 4. Part B says work out the lowest common multiple of 6 and 8. Again, because the numbers are quite small, I'm just going to list out numbers in the 6 times table. 6, 12, 18, 24, 30, and then start listing out numbers in the 8 times table. 8, 16, 24, 32, 40. Now, after a little bit of time, you should find that you've got one in common. I just noticed I've got a 24 in both there. So that is going to be my LCM then, isn't it? So the answer is 24. Question 5, complete the boxes using a factor of 12 and a factor of 40, and they have to multiply together to give us 30. Okay, so I think I'm just going to list the factors of 12 first, and then the factors of 40, and then see if I can find a pair that go together. So I've done factors of 12 so many times now, I could probably do it in my sleep. 1 and 12, 2 and 6, 3 and 4, and 40. 40 is going to be 1 and 40, 2 and 20, 3, no, 4, yep, 4 and 10, 5, yep, 5 and 8, 6, no, 7, no. And I've met myself coming back down the other way now, haven't I? Because I've tried all the numbers between 5 and 8 and there wasn't one. So there are all the possibilities, and I want to find two numbers that multiply together to give me 30. So I'm thinking if I pick the 6 from there and the 5 from there, 6 times 5 is 30, isn't it? So I'm going to go for 6 here and 5 here. Now I could have also had 3 and 10, that would have worked as well. Is there any other pairs? I think that's just the only other one that can be. So 3 and 10 or 6 and 5 both seem to work. Okay, question 6, write 300 as a product of prime factors. Now you can do this as a factor tree if you don't have a calculator with the function. So you'd write 300 at the top and you do 2 branches coming off it, and you think, well, what two numbers multiply together to give me 300? Well, I could have 30 and 10. Doesn't really matter which ones you pick. It always comes out the same way each time. And then you keep going. You say, well, what numbers multiply together to give me 30? Well, that's 3 and 10. And 10 multiplies together, which is 2 and 5. Now, they're both primes, and so I can stop there, and so is 3. But 10 isn't, so I'm going to keep breaking that down. And I'm going to get 2 and 5 as prime factors of those two. Okay, and then once you've got all your branches ending at primes, then we can just list out our answer then. So 300 then is going to be 2 times 2 times 3 times 5 times 5. We tend to write them from smallest to biggest, so it's going to be 2 times 2 times 3 times 5 times 5. Okay, now if you've got a calculator with the function on it, any of the CASI ones tend to have it, so it's got the fact button on it, isn't it? So if you just type in 300 and then equals, so the 300 is on your display. Now if you've got the older style Casio, then you then press shift and then the fact button, and then it will write it down there. But if you've got the newer Casio, which I have here, then you would go down and hit the format key and then go down the list and pick out the product of prime factor button, which is this one, and then it will write the number as a product of primes, and it's written down 2 squared times 3 times 5 squared. Now that's the index form, that's perfectly acceptable. Either way, it doesn't really specify here, so you can either write it in expanded form, 2 times 2 times 3 times 5 times 5, or in index form, 2 squared times 3 times 5 squared. Either form is fine. Now, but this one though, it insists on writing our numbers in index form. I'm just going to tap it into the calculator this time. I've shown you how to do it long. If you don't have the button on your calculator, you do it the same way if that's the case here. I'm just going to press 140 and then execute, and then I'm going to press the format key and then turn it into a product of primes. Okay, if you don't have this newer calculator, just use the fact key again. Now you can see it's already given it to me here in index form. I just need to copy down what's on the screen for 3 whole marks. Wowzers. So that's just 2 squared times 5 times 7 for a quick tap onto the calculator. Very nice. Okay, on to the next section, which is perimeter. Perimeter is the distance around the edge of a shape. So in this shape here, you'd be adding together that side, and that side. Okay, so we're finding the fact we know the length at the bottom of the triangle, but we don't know the 2 other sides. Now this is an isosceles triangle, which means that these 2 sides are the same. Look. And I'm told that the perimeter of this triangle is 22 centimeters. Oh, so we're working backwards here to find the length. Okay, so if I take the base of the triangle away from 22, it should give me the length of the other 2 then, shouldn't it? So if I say 22 minus 4, that gives me 18. Okay, so that means that these 2 together must be 18. And then so if I then divide 18 by 2, that gives me 9. So that side must be 9 and that side must be 9. So the side AB then is going to be 9, isn't it? Question 10, lines A, B and BC are shown on the centimeter grid. Yes, they are. Write down the coordinates of the point A. Well, the coordinates of point A is here, isn't it? So when you're doing coordinates, it's along the corridor, up the stairs. So 1 along, 3 up. That's going to be coordinates 1, 3. ABC are 3 corners of a rectangle ABCD. Complete the rectangle on the grid. Okay, so this is a rectangle, one of its corners missing. So yeah, it's going to be here, isn't it? That's where it goes. That's the coordinate there. So complete the rectangle on the grid. Okay, so that's the corner. I'm going to label it D, and then I'm going to join it together into a rectangle by adding that side in and that side. Back up to the top, I guess. Yeah, like that. So there's my rectangle. And it says work out the perimeter of ABCD. So the perimeter then is all the sides added together. So the perimeter then is going to be, well, how long are the sides here? Well, the top sides are 4, aren't they? They're 4 squares along, and the other sides are 3. So if you're going to go all the way around this shape, you would go 4, 3, 4, and 3, won't you, all the way around? So adding those together, 4 plus 3 plus 4 plus 3, that gives me a total of 14 units, whatever the units happen to be here. Question 9. On the centimeter grid, draw one rectangle with a perimeter of 20 and an area of 24. Okay. Now, if you think about it, area you get by multiplying the length and the width together. So if I've got 24, then if I find the factor pairs of 24, then my sides of my rectangle must be a factor pair of this number. It's going to be one of the pairs I write down here. So the factor pairs of 24 are 1 and 24, 2 and 12, 3, yep, 3 goes into 24, it goes in 8 times, 4, yep, 4 goes in 6 times, 5, no it doesn't, and then I've met myself coming down the other way, haven't I, because the next number is 6, so that's as far as I need to go. Okay, so that means that one of these pairs is the pair that I need. Now, if you think about a rectangle, it's got like length and width and length and width. So 2 sides of it, the length and the width, should add up to half the perimeter, shouldn't it? Because the other half is the other 2 sides, isn't it? That length and that width. So if I know what the perimeter is and I halve it, that should tell me what the length and the width add up to. So the perimeter being 20, if I take 20 and I divide it by 2, I'm going to get 10. So my length and width here need to add up to 10. So which factor pair adds up to 10? It's going to be this factor pair here, isn't it? It's the 4 and the 6. Okay, so 4 plus 6 is 10. So then double that up. That's going to give me the perimeter of 20, and multiplying it together, it's going to give me the area of 24. So I just need to draw a rectangle which is 4 by 6. So just pick some points. There's a point to start with then. So I'm going to count 1, 2, 3, 4, 5, 6 along, and 4 down, and 6 along, and 4 back up again. Okay, and then joining that together, I'm going to get my rectangle. Okay, so there we go, there's my rectangle drawn. Question 11. This shape is made by cutting out an equilateral triangle from a square. Work out the perimeter of the shape. Okay, so the equilateral triangle must have had a baseline here then, isn't it? Now I know that all the sides of an equilateral triangle are the same, and the base of this equilateral triangle is the opposite side of my square, isn't it? So that side there must be equal to that one there, so that one must be 5.2 as well. But because this is an equilateral triangle, then that must be 5.2 and that must be 5.2 as well. Okay, and because it's a square, this must be 5.2 and this must be 5.2 as well. So that's 5.2 and that's 5.2. Okay, so what is the perimeter of this shape then? It's going to be all of those sides added together. So it's going to be 5.2 plus 5.2 plus 5.2 plus 5.2 plus 5.2. How many 5.2s was that then? That's 1, 2, 3, 4, 5 of them, isn't it? It's actually a pentagon. Okay, so this is a 5-sided shape. So if I take my 5.2 and I multiply it by 5, I should get the perimeter of this shape. Okay, I'm not being a hero, I'm just going to type it into the calculator. 5 times 5.2, that comes out to be 26. So my answer is 26 centimeters. Question 12. A triangle has perimeter 32 centimeters. A square has perimeter 40 centimeters. Two sides of the shapes are put together to make a pentagon. Work out the perimeter of the pentagon. Okay. Right, now I'm going to start with the square because the square I know everything about, don't I? Now if this square has got a perimeter of 40, and that perimeter is gained by adding those 4 sides together, isn't it? Okay, so if I know that the perimeter is the 4 sides added together, and I know because it is a square all those 4 sides are the same, that means that each side must be the total perimeter 40 divided by the number of sides, which is 4. That gives me a width of the square of 10. It's like a square of side 10. Okay, so that means that is 10, that is 10, that is 10. Okay, now because this line here fits along this line here, then it must be that that side there is 10 as well, mustn't it? Otherwise it wouldn't sit on nicely like a hat on top of the square. So that side must be 10 as well. So that means that these two sides added together must be 32. The total perimeter, 32, minus the 10 we had there then. So these two sides here are going to be 32 minus 10, which is 22. Okay, now I don't know which side adds up to, I don't know what the exact which side is the length of, now I don't know the exact length of each of those two sides, but I know they combine together to give me 22, and that's all I really need to know actually, isn't it? Because if you think about it, these two lines here I know must add up to 22, plus I know I've got my 10 and my 10 and my 10. That means I've got all the sides now, isn't it? I know all of them. So I know this perimeter then is going to be the 22 from the two yellow sides, plus the 10, plus the 10, plus the 10 from the 3 external sides of the square. Okay, so what does that add up to? 22, 10, 10 and 10, that adds up to 52, isn't it? So that is my perimeter of this shape. This is going to be 52. Okay, next up we got frequency trees. Frequency trees are quite logical things really. You just need to read it through and kind of work them out as you go along. So 60 people took the test. So we can see this 60 people that they're talking about here. They're the 60 people. Before the test, they predicted whether they would pass or fail. So 40 people predicted they would pass. Okay, 40 people would predicted they would pass. Now where is that on the diagram? So pass is here. So this is the 40 people here that predicted they would pass. So I can just write the number 40 in there because we know that from the question. Okay, now the next thing says 32 of the people who predicted they would pass did pass. Okay, so of those 40, 32 of them actually did pass. Okay, so this circle here is the ones who thought they would pass and did pass. So then that goes 32 in there. Okay. Now the next line says 51 people passed altogether. Now 51 people passed altogether. Now that is this circle and this circle combined, isn't it? They're the ones who passed altogether. Okay, so either they thought they would pass and they'd pass, or they thought they would fail and they would pass. Okay, so if there are 32 up there and then together they equal to 51, then this one is going to be 51 minus 32. What's 51 take away 32? That's 19, isn't it? So that one's 19. So there is 19 people in here. Okay, now that's all the information I've got. Now it says go on to complete the tree, but I've got enough information now to finish it off. Okay, right, let's have a look at the first row then. I've got 60 people altogether, and I know of those 60 people, 40 thought they would pass, they predicted they would pass. Now that means the remainder, which is 60 minus 40, 20 of them must have thought that they failed then, mustn't they? Because 40 and 20 makes 60. Okay, doing the same thing from those who thought they would pass and then went on to pass or fail. So I know that there are 40 people who thought they would pass, and of those 40, 32 actually did pass. So the difference between 40 and 32, which is 8 must be the number of people who thought they would pass but then actually went on and failed, because 32 plus 8 is 40. Now similarly down here, okay, of the 20 people who thought they would fail, 19 people actually passed. Okay, that's interesting. So more people who thought they would fail passed then, or a bigger proportion did, than the people who thought they would pass. Okay, so confidence isn't always the best. So if you thought you passed your maths exam today, maybe you failed. And if you thought you failed, maybe you were more likely to pass. I don't know if that's what it's saying, but I do know that there must be one in here, okay, because the 19 and the 1 make 20. Question 14, 480 people are asked if they eat sushi. The correct answer is yes. 20% said yes. Only 20%? What? Right, so what is 20% of 480? So 20% said yes of this 480 people here. So what is 20% of 480? Well, if I turn that into a multiplier, 0.2, and times it by 480, it's going to tell me how many people that is then. So I'm just going to type it into my calculator, 0.2 times 480, and that comes out to be 96. Okay, so that means 96 people eat sushi, and that means everybody else doesn't eat sushi. So 480 minus answer, I'm going to type into my calculator, that tells me 384 people foolishly do not eat sushi, which is delicious. Okay, and then 2/3 of the people who say yes eat sushi at least once a month. Okay, so I need to find 2/3 of my people who say yes. So what is 2/3 of 96? Okay, and I can just type that into the calculator as it is. I'm going to use the fraction key. Hit the fraction key. 2 on the top, 3 on the bottom, 2/3 times 96. This is the calculator paper, not taking any chances. I'm going to let the calculator do my thinking for me where it can. So 2/3 of 96, that's 64. Okay, so if 64 said yes, then how many said no? It's going to be the difference between those two numbers, then, isn't it? So it's going to be 96 minus 64 is going to be the other branch. That is 32. Okay, all done. Question 15, 50 people took a test. Before the test, they predicted whether they would pass or fail. 30 people predicted they would pass. 36 people did pass. Of these 36 people, 3 times as many predicted pass as predicted fail. Complete the frequency tree. Okay, so I've got 50 people all together, and you can see that here at the circle at the top. Now we then predict that 30 people predicted they would pass. So prediction pass is here, so I'm going to write those 30 people in here. So if 30 people thought they would pass and there were 50 altogether, there must be 20 on the other branch down there. So 30 plus 20 is 50. Okay, now 36 people did pass. Now the 36 people who passed are actually in two places. They're going to be here and they're going to be here in those two places there, pass and pass. Okay, so we know that there are 36 people in there, but of those 36 people, 3 times as many people passed as predicted fail. So that means that the people who predicted pass to the people who predicted fail were in the ratio of 3 to 1. Okay, so that means 3/4 of them predicted pass and 1/4 predicted fail, because I just added the 3 plus 1 together, got 4, so I knew there must be 4 parts. So 3 out of 4 pass, 1 out of 4 fail. Okay, so if I want to know how many people are in here, then I'm going to have to find 3/4 of the 36 people who passed them, aren't I? Okay, so what is 3/4 of 36? So again, I'm just not going to take any chances. I'm just going to do 3/4 as a fraction on my calculator, and I'm going to multiply that by 36. That comes out to be 27. Okay, so that means 27 must go in there. So in the other box down here, that must be 36 people passed, 27 passed who thought they would pass, so the difference 9 passed who thought they would fail. Okay, then we can just finish off the boxes again. So I've got 30 and 27 on the top branch, so there must be 3 here. I've got 20 and 9 on the bottom branch, so there must be 11 here, so it all balances out. Okay, so that's that one done. Question 16. Some students were asked about their daily exercise. 12 more students answered yes than answered no. Complete the frequency tree. Okay, so 12 more students answered yes than answered no. 12 more students answered yes than answered no. So I know that 35 people answered yes, and I don't know how many people answered no, but I know that 12 people more answered yes than answered no. So if 35 people said yes and 12 more people said yes than no, then this box down here must be 35 subtract 12 then, mustn't it? So what's 35 subtract 12? 35 subtract 12 is 23. So I must have had 23 people saying no. So then altogether, how many people were there? So if I add these two together, 35 plus 23, that comes to 58. So there must have been 58 people altogether. Okay. Right, then of those 35 people who said yes to exercise taken, 27 did it for at least an hour. So the rest, 35 minus 27, must have done it for less than an hour. So 35 minus 27, that is equal to 8. Okay, so I've finished off my frequency tree now. Now the next part says one of the 35 students who answered yes is chosen at random. What is the probability that they exercised for at least 1 hour? Okay, so we're not talking about the whole tree. It's one of the 35 students who answered yes. So it's this part of the branch that we're dealing with here. Okay, so what is the probability that they exercise for at least an hour? Well, probability of at least 1 hour is going to be successful outcomes. How many people did exercise for at least 1 hour? That was 27, divided by total outcomes. How many people were there altogether who took exercise? It was 35. Okay, so that's my answer. It's going to be 27 out of 35. Next up, we've got algebraic expressions, and question 17 says simplify fully 3a plus 5c minus a plus 6c. So we've got two types of term here. We've got terms in A, I've got 3a and minus a, and we've got terms in B, which is 5c and 6c. Okay, so collecting the a's together, what is 3a minus a? Now you notice when I circled them, I circled the signs as well that were in front of them, because the sign belongs to the letter after it. It's got nothing to do with the one in front of it, or everything to do with one after it. So that is 3a minus a. So if I got 3a and I take away a, that's 2a. Okay, so I get 2a from the yellow bits. And I've got 5c plus 6c. that is 11c, okay, from the green bits. And that's my final answer then. It's going to be 2a plus 11c. Right, question 18. This time I've got 7c and minus 4c, and I've got 5d and 3d. So add in the c's together. 7c minus 4c is 3c. 5d plus 3d is 8d. So it's 3c plus 8d. Next up, I've got 12x squared minus 8x squared minus 5x plus 2x. Now, all these terms have got to do with x, but these ones have to do with x squared, and these ones have to do with x. So these are different types of different types of terms. X squared terms are different from x terms. So collecting the x squared terms together, I've got 12x squared minus 8x squared. That leaves me with 4x squared. And I've got minus 5x plus 2x. Now, if you're at negative 5 on the number line and you add on 2, it's going to take you up to negative 3. So that's going to give me minus 3x altogether. So 4x squared minus 3x is my final answer. Question 28, simplify y times y. Well, when you times something by itself, you square it, don't you? So that's going to give me y squared. And simplify 5a plus 2 minus a plus 9. So we've got terms in a, and we've got numbers. We call these constants, actually. So I've got 5a and minus a, which are going to combine. 5a take away a, that's 4a. And I've got 2 plus 9, that's 11. So 4a plus 11. And then question 21, simplify fully 8a plus 5b plus 6a minus 2b. So I've got terms in A, I've got 8a and 6a, and I've got terms in B, I've got 5b and minus 2b. So adding the a's together, 8a and 6a, that makes 14a, and adding the b's together, 5b take away 2b, that's 3b. So 14a plus 3b. Getting a little bit more complex now, so I've got 2 lots of 4a plus 9 plus 15a over 3 minus 7. So I've got a bit of tidying up to do before I can collect like terms together this time. Now, first off, contents of this bracket here, 2 times 4a. Well, if I've got 4a and 4a, that makes 8a, doesn't it? So that bracket becomes 8a. Then I've got plus 9, and then I've got 15a divided by 3. Well, 3 goes into 15 5 times, so that 15a divided by 3, that's going to be 5a, and then I've got minus 7 on the end. Okay, so now I've got terms in A, I've got 8a and 5a, and I've got numbers, I've got 9 and minus 7. Okay, so add in the 8s and the 8a and the 5a together, 8a and 5a make 13a, and then 9 plus negative 7, that's 9 take away 7, isn't it? That's 2. So 13a plus 2. 13a plus 2. 23, simplify d times d. When you times something by itself, you square it, it's d squared. And simplify fully p squared times p. Well, if you've got p squared, which is p times p, and you multiply it by another p, you've actually got p times p times p, which is the same thing as p cubed, isn't it? Or another way of thinking about it is laws of indices. When you've got two numbers with the same base, p, and you multiply them together, you add the indices. You've got the 2 and that kind of silent 1 that's there, giving you 3 altogether. Question 25, match each expression on the left with one on the right. One has been done for you. So I've got a plus 3 plus 2, that's a plus 5. I've got a plus 3 times 2, 3 times 2 is 6. So that goes with a plus 6 up there. A times 3 times 2, 3 times 2 is 6, that's going to give me 6a, and a times 3 plus 2, that's going to be 3a plus 2, it's that one down there. Question 26, expand w lots of w plus 6. So I'm going to multiply out this bracket by multiplying everything inside the bracket with the w. So w times w is w squared, and w times 6 is 6w, so it's just going to be w squared plus 6w. Okay, now I've got two different brackets here. It's not two brackets multiplied together, it's two single brackets which are then added together, or in this case subtracted from each other. So multiplying out the first bracket, I've got 5 lots of 3x and 5 lots of 4. 5 times 3x is 15x, 5 lots of 4 is 20. just take care with this. I've actually got negative 2. Negative 2 times x, that's minus 2x. And then negative 2 times negative 1, that's going to give me negative times negative is positive, is plus 2. So then we just need to collect like terms, don't we? So I've got a term in x there and a term in x there, and I've got a number and a number. So collecting the x's together, 15x minus 2x, that's 13x, and 20 plus 2, that's 22. So that's my final answer then, 13x plus 22. Question 28, expand and simplify fully. Again, I've got two brackets, two single brackets, which are then combined together. I haven't got a double bracket that I'm multiplying out. Okay, so the single bracket, the first single bracket first, 4 lots of 2c and 4 lots of 3. That's going to give me 8c plus 12. Then I've got kind of an invisible 1 there. I've got minus 1 lots of 5c minus 1. So my invisible minus 1 times 5c, that's going to give me minus 5c there, minus 5c. And I've got minus 1 times minus 1, and again that is positive 1 at the end there. So I've got terms in c, I've got 8c minus 5c, that's going to give me 3c. And then I've got 12 plus 1, that's 13. So I'm going to get 3c plus 13. That's my final answer. 3c plus 13. Question 29a, multiply out 3 lots of 2x minus 7. So 3 lots of 2x, that is 6x. And 3 lots of minus 7, that is minus 21. So that's 6x minus 21. Factorize x squared plus 8x. Okay, so we've got two terms here. They've both got an x in them. So if I take x outside and put it on outside of the brackets like that, and I think, well, what times x is x squared? Must be x. And what times x is 8x? Must be 8. So the factorized form is going to be x plus 8. Question 30, multiply out 3 lots of 2x plus 5. So 3 lots of 2x, that's 6x. 3 lots of 5, that's 15. So don't know why that ended up looking like that. It should be 6x plus 15. Okay. Factorize 8x minus 4. Now both these terms have got 4 in common. So if I write 4 on the outside, 4 times what is 8x must be 2x. And 4 times what is minus 4? It must be minus 1. So my bracket is 4 lots of 2x minus 1. Question 31, factorize 2x plus 28. Now 21 and 28 are both in the 7 times table. So I can take 7 out as a common factor. 7 times what is 21x? It must be 3x, mustn't it? 7 3s are 21. And 7 times what is 28? It's 4. So that is 7 open brackets 3x plus 4. Question 32, factorize 15x plus 5y. Well, 15 and 5 are both in the 5 times table, so we can take 5 out as a common factor. 5 times what is 15x has got to be 3x, and 5 times what is 5y must be y, mustn't it? So then that is 5 lots of 3x plus y. 33, factorize 12a plus 15b. Well, the a's and b's are not common, are they? But 12 and 15 are both in the 3 times table. So let's take 3 out of them. So 3 out of 12a is going to leave 4a. 3 out of 15b is going to leave 5b. So that's 3 lots of 4a plus 5b. Question 34, factorize 15x plus 35y minus 40z. And I've got 3 terms here. What do they each have in common? They're all numbers in the 5 times table. Okay, so if I take 5 out and put it in the front, well, 5 times what is 15x must be 3x. 5 times what is 35y must be 7y. And 5 times what is 40z must be 8z. Okay, so 5 lots of 3x plus 7y minus 8z. Question 35, factorize fully. Now note the change of wording, like all the way through. This was factorise, 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 and now suddenly we've got factorise fully. Now this is a dead giveaway that there is more than one factor. Okay, so if you see factorise fully, it 999 times out of 1,000 indicates that there are two factors that you need to pull out. Okay, so the first thing these numbers have in common is 2, because 2 and 6 are both in the 2 times table, so 2's common. But x squared and x have both got an x in them, so I'm going to have to take an x out as well. So when it says factorise fully, it nearly invariably means that there are two factors or more. Okay, so if you just partially factorise it, if you just took out the 2 or you took out the x, you'd only get one of the two available marks. Okay, so 2x out of x squared leaves x, and 2x out of 6x leaves 3. So it's 2x lots of x plus 3. Okay, so again, if you partially factorised it to 2 lots of x squared plus 3x, can you see that your expression here have both got x's in? So it's not fully factorised, it's only partially factorised. And again, if you brought the x out and you'd had 2x plus 6 inside your bracket, then this 2 and this 6 have got 2 in common, so it's only partially factorised. Okay, so both those versions would be worth 1 mark. This fully factorised version would be worth 2. Next up, Pythagoras Theorem. So we should know that c squared equals a squared plus b squared. I hope so, because we're going to be using it a lot today. So what have we got? Use Pythagoras Theorem to work out the value of x. Okay, well there's x over here. It's the long side of the triangle. So we're going to be squaring and adding and square rooting here. So x squared is going to be the other two added together and squared. Then it's going to be 32 squared plus 60 squared. Now you can just type that all into your calculator in one long go if you want to. So if you just press the square root key first, and then under the square root we're going to type 32 squared plus 60 squared, like that. So it should look like that. Square root, or that square root needs to go all the way across from one end of the 32 squared all the way to the end of the 60 squared. If it's looking correct, just press equals. You can see it popped out being 68. So that is my value of x. Okay, so x then is going to be 68. Because I put the square root in, it's already square rooted. That's just the final answer. So I'm going to write down 68. Now, I do recommend writing this down though, because you are banking your marks there as you go along. If you just write down 68 and you mistype something into your calculator, you're banking on, you're throwing all those 3 marks away if you get it wrong. Okay, so make sure you've actually written down what you type into the calculator. Okay, right, and then question 37. Now this time y is the shorter side, so if I'm going to use Pythagoras theorem here, y squared is going to be the larger side, the 14 squared, the hypotenuse squared, minus the other one squared. So if you're looking for the long side, you square and add and square root. If you're looking for the shorter one, you square and subtract and square root. So I can type that in all in one go onto my calculator. Hit the root key, type in the 14 squared, press minus, type in 9 squared. Now if you put them in the wrong way around, if you write 9 squared minus 14 squared, your calculator is going to give you an error. Okay, it has to be the big one first. Now you notice that this one's coming out to be as a root, so I'm going to convert that into a decimal, and you can see I'm getting 10.7 and change. So give your answer as a decimal. 3 significant figures is usually a good idea, unless it tells me anything different. It just says give it as a decimal here. 3 is sensible. I'm going to write down 10.7. Question 38. Work out the length of x. Give your answer to 1 decimal place. Now again, x is the long side, so I'm going to be saying x squared is the other 2 squared and added together this time. I'm going to type that in all in one line into my calculator. Square root 16 squared plus 9 squared. That comes out to be root 337. So then turning that into a decimal, I get 18.357. I'm going to have to round up if I want to go to 1 decimal place after the 3. Next digit's a 5, which means I need to round up. So my 18.3 is going to round up to 18.4. Okay, that's my final answer. Now, if you are not very good at rounding, then just write the whole thing down first. So you know yourself if you get these wrong often, when you round the wrong way or whatever. If you write the whole thing down, your whole calculator display, okay, can you notice this is worth 4 marks? Like the rounding part is only worth 1 mark, okay? So if you've written the full calculator display down and then you round it off wrong, you're still going to get 3 marks out of 4, okay? If you didn't write the full answer down, you might not get all those three marks. You might not get many. You might just get a mark for writing this bit down. Okay, so just make sure that if you're not very good at rounding, if you often get it wrong, maybe you write the full display down before you write your final answer. Question 39, x again is one of the shorter sides, so x squared is going to be 8 squared minus 3 squared. Square your other 2 sides and then subtract. Again, you need to make sure your big side is the first one, otherwise you're going to get a calculator error. Root 8 squared minus 3 squared. That comes out to be root 55, and as a decimal, that is 7.416. I'm going to round it off to 3 significant figures because it hasn't specified. So I'm going to write down, I'm going to round it off after the 1. Next digit is a 6, so again it's rounding up here. So that's going to be 7.42 rounded up. Again, if you're not very good at rounding, why don't you just write the interim value down just to be on the safe side. Only takes like a second. You're kind of banking your marks up until that point, and then if you make a catastrophic rounding error, you're still going to get 2 of the 3 marks. Question 4, a shape is made by joining a right angle triangle to a rectangle. Work out the area of the shape. Okay, so we need to work out the area of the shape. Now this area is made up of 2 shapes. It's made up of a triangle. The area of a triangle is equal to half base times height, isn't it? And then I've got this part here, which is a rectangle, and that is equal to length times width. Okay, now the triangle we know everything about that we need because we've got the 2 sides at right angles to each other. The base and the height need to be at right angles to each other, and I know the base here, look, it's 30, and I've got one at right angles to it. I've got the height, so that's 16. So I can work that one out straight away. Half times 30 times 16. So half of 16 is 8. I'm just going to type in 30 times 8 because it's easier to type into the calculator. 30 times 8, that's 240. Okay, so that's the area of the triangle bit. So we need to work out of the rectangle, but oh no, look, we've only got one side of the rectangle. We know the length, it's 52, that's that side there, look, but what's this side? I don't know. We're going to have to work it out, aren't we? Well, that side there is the same as that side up there, and that side up there is the hypotenuse of that triangle at the top, where we know 2 sides. So if we use Pythagoras Theorem, we can find that length first, can't we? So if we call this x, then x squared is going to be 30 squared plus 16 squared, because x is the long side. So then typing into my calculator, square root 30 squared plus 16 squared, that comes out to be 34. So x is 34. So that means that side there must be 34. And now I can work out the area of the rectangle. So the area of the rectangle is going to be 52 times the width, which we just worked out to be 34, times 34. Okay, so 52 times 34 into my calculator, that comes out to be 1,768. Okay, and then therefore the entire area is going to be the area of the triangle plus the area of the rectangle, which is going to be 240 plus 1,768, and that comes to 2008. What are the units? Everything is in centimeters. This is area. It's going to be centimeters squared, isn't it? 2008 centimeters squared. Next up, we've got angles, and question 41 says here are 2 different straight lines. Work out the size of angle x. Now, here we've got angles on a straight line. Angles on a straight line sum to 180 degrees. So x plus 62 is equal to 180. So to find x then, we're going to have to subtract 62 from both sides, aren't we? So if I take 62 from this side, it leaves me with x. If I take 62 from the far side, 180, subtract 62, that is 118. Okay. Question 42 says, in a triangle, two of the angles are 51 and 74. Work out the size of the third angle. Okay, so let the third angle be x. Then my three angles, x plus 51 plus 74, must be equal to the interior angles of a triangle, which always add up to 180 degrees. Okay, so adding these two together first, 51 and 74 added together, that gives me 74, 124, 125, isn't it? So that's x plus 125 is equal to 180. So then taking 125 away from both sides, that's going to leave me with x is equal to 180, take away 125, that is 55 degrees. Question 43. The diagram shows a triangle ACD and an equilateral triangle BCD. Work out the size of angle X. Not drawn accurately. Yeah, it doesn't look like an equilateral triangle. BCD is an equilateral triangle. BCD is equilateral. BCD. It's this triangle here. This is the equilateral one. That means all of the sides are the same, but more than that, all the angles are the same. So if you've got three angles that add up to 180 and they're all the same, if you divide 180 by 3, you're going to get 60, aren't you? So that's 60, 60, 60 along there. Okay? So we want to work out x down there. How are we going to get down there? Okay, well, we've got angles on a straight line here, haven't we? So if we know that one's 60 and that these two add up to 180, then this angle here must be 120. 120 and 60 make 180. Then I've got 2 out of the 3 angles in my triangle. So x plus the 20 plus the 120 is equal to 180. So 20 and 120 is 140, isn't it? So x plus 140 is equal to 180. So then taking 140 away from both sides, and that's going to leave me with x is equal to 40. That's my final answer. Question 44. ABDE is a parallelogram. Where's that then? ABDE. ABDE. That's a parallelogram. Okay, so if it's a parallelogram, I can put little arrows on here and here because they're parallel. I can put little arrows on here and here because they're parallel. Now I'm additionally told that AB is equal to AC. So this side here is equal to this side. Incidentally, it's equal to that one as well, isn't it? But I'm not sure that's going to help us very much. So that means ABC is an isosceles triangle, isn't it? I don't know how that helps us just yet, but I'm sure it will. Right, so we want to work out x. Now, always start where you know the most things, okay? And we know the most things over here in this triangle here, don't we? We know 2 of the 3 angles. So it's fairly easy then to work out my other angle here. So I can work that one out then because that angle plus the 68 and the 82 add up to 180. So 82 and 68, what's that? That's 90, 150. Taken away from 180, then this angle here must be equal to 30, okay? Now, because ABDE is a parallelogram, it also means that we've got angles in parallel lines, and don't I? So AE and BD are parallel, and we've got lines crossing them. So this angle up here, look, the 30-degree angle, that is actually alternate to this angle down here. This is going to have to be 30 as well, because they're alternate angles in a pair of parallel lines. Okay, if you've got a pair of parallel lines, which I do, like the top line of my parallelogram and this one, and then I've got the line AD crossing them, then that one and that one are alternate angles. They're my 30 and 30 I've got on my diagram. So this one and this one are the 30 and the 30, aren't they? Okay, so you have to be able to see these more simple shapes within a more complex diagram if you're going to be good at these sort of questions. Okay, can I work out x yet? No, I cannot, because I still don't know enough. Okay, but I do know that opposite angles in a parallelogram are equal. So that angle there and that angle down there must be the same because it's a parallelogram. So that angle there is 68. Okay, So if that angle there is 68 and that angle there is 68, and this is an isosceles triangle, so then this one must be 68 as well. And if that's 68, then because of angles on a straight line adding to 180 degrees, then that angle on the other side then must be 180 minus 68, and that is 112. Okay, now I know that's 112, then x is going to be x plus 112 plus 30 must be equal to 180 because of angles in a triangle. So then x then must be 112 plus 30, 142, taken away from 180, and that leaves me with 38. So x has to be equal to 38 degrees. Now again, it doesn't look like it looks skinnier than that, but it's not drawn to scale. So I'm just going to assume that that is the right thing. Question 45, A, B, C and D, E, F, G are parallel lines. B, E, H is a straight line. Okay, work out the size of angle X. Where's X? It's all the way over there. So I want to work out that angle X over there. Now again, we've got a pair of parallel lines here and here. Look, they've got arrows on the end, and we've got a transversal crossing them here. So do you know what we call this angle here and this one here? These ones are called co-interior angles, aren't they? And co-interior angles sum to 180 degrees. So my X angle and the 25 add up to 180 degrees because they're co-interior. So that means that X must be 25 taken away from 180. That's 155 degrees. Now, can I work out Y? Well, again, I've got a pair of parallel lines, okay, and I've got another transversal crossing them in this direction, okay. And this angle down here, that's one of the angles in a pair of parallel lines and a transversal. Now, this one up here, the 25 and the right angle, must be corresponding then to that Y, mustn't it? They're corresponding angles. So I can say then that Y must be equal to 25 plus 90 because they correspond to that big angle there. Those two things combined together. So 25 and 90 make 115. So Y must be equal to 115 degrees in this case. Question 46a, part of a regular polygon is shown. Assume that the polygon is an octagon. Work out the size of angle X. Now, angle X here is what we call an exterior angle. Now, we're told this is a regular polygon, which means all the angles are the same. So the exterior angle of a regular polygon is given as 360 degrees but divided by the number of sides, in which we're assuming the number of sides is 8 in this case. So 360 divided by 8, what's that then? 360 divided by 8, that comes out to be 45 degrees. So according to it being an octagon, it's going to be 45 degrees. I assume with the assumption there, they're going to change their mind in a minute. Oh look, here they go. In fact, the polygon has more sides than an octagon. What does this mean about the size of angle X? Okay, so if the number of sides is greater, then that means this n here is going to be greater. Okay, so if you increase the denominator of a fraction, do you make the fraction bigger or do you make the fraction smaller? So imagine I had like 2/3. Can you imagine 2/3 of something? It's about like that, isn't it? That's 2/3. Now if I increased the denominator by 1 to 2/4, can you see my fraction's actually got smaller? So if you make the denominator bigger, then the amount of space you've got is actually smaller. So if I increase the divisor here, my number is going to end up being smaller than it was. So if it's not an octagon, it's got more sides, then the exterior angle is going to be less. So it is less than the answer to part A. Question 47, part of a regular polygon with 15 sides is shown. Work out the size of an interior angle. Now there is a formula for a regular interior angle, and it is n minus 2, the number of sides take away 2, the number of triangles inside your shape, times 180 divided by n. That's quite a complex formula. I don't like using that formula. I tend to work out the exterior angle because it's easier. So the exterior angle is going to be 360 divided by the number of sides. In this case, it's 360 divided by 15, isn't it? So 360 divided by 15 is 24. And I use the fact that an exterior angle and an interior angle lie in a straight line. So if I know that angle there is 24, and I know that these lie in a straight line, then this angle then is going to just be 180 minus 24, isn't it? So the interior angle is going to be 180 minus whatever we find the exterior angle to be. Now I just find that easier to work out and use in practical terms than this formula over here. Although that will get you there in one go, it's a more complicated formula. I think it's easier just to work out the exterior angle and then subtract from 180 to find the interior angle. But you do you. If you like to use that big complicated formula, you go ahead. Okay, I'm just going to stick to the easy one. Right, question 48. A regular polygon has an exterior angle of 20. Work out the number of sides of the polygon. Okay, well we've just been using this twice then. Exterior angle is equal to 360 divided by n. Okay, so if we're saying that the exterior angle is 20, then I've got 20 equals 360 divided by n. Now if I cross multiply my 20 and my n, switch these around, or another way of thinking about it is multiplying both sides by n and dividing both sides by 20, I'm going to get n is equal to 360 divided by 20. So what's that? 36 divided by 2, that's 18. It's going to have 18 sides. Right, moving swiftly on, we're on to linear graphs now. And question 49a says complete the table of values for y equals 2x plus 1. Now mostly it's done, I've just got one box to fill in. Now the y value is 2 lots of the x value plus 1. So if I take the x value and I imagine it here, look, 2 lots of 3 plus 1, what's that? 2 times 3 is 6 plus 1, that's going to be 7. Okay. Now if it wanted me to do more values, I might use the table function on the calculator, but really for one value it's not worth the effort. So now I've got the points. Let me plot them then. So the first point I'm going to plot is minus 1, minus 1. So just take care of minus 1. Oh look, they've got a different scale here. So minus 1 is actually here. Okay, because the scale on the x-axis, can you see it's going up in 2 squares for each unit, whereas it's going up 1 square on the other one. So minus 1 is on. 1, 3, that's there, look. And then 3, 7. 3, 7. Okay, once you've got them all lined up, then you grab your ruler and then draw a straight line through all of them. Okay, now don't start and end with your first point. Kind of stretch out the full width of your paper like that. Okay, full width of the axes. Then part C says, on the grid, draw the line y is equal to 5. Now, when you've got an equation y is equal to something, to a number, it's going to be a horizontal line. X is equal to number is a vertical line, y is equal to number is a horizontal line, and it's a horizontal line going through whatever that value is there. It's 5 in this case. So we're going to find 5, and we're going to draw a line through it like that. Okay, so that's my line. Y is equal to 5. Question 50, complete the table of values for y equals 8 minus 2x. Now you can just work them all out like I just did earlier, or you can use the table function on your calculator if you want to. I'm just going to quickly show you that. I'm going to click on the menu button and I'm going to go to the table function. Now I need to type in the formula, so I do that by pressing options and then this option here, and I'm going to type in the function 8 minus 2x. Where's x? It's there, look. 2x. And then Next thing I'm going to do is I'm going to put in the range of possible values again. So again into option, and then I'm going to put the lowest value on my table, which is a 0 as my starting value, and I'm going to put my end value as the last value up here, and these numbers are going up in 1, so my step is 1. Okay, when I type those in and press equals, then all of the table of values is generated. Now you notice it should match up with the values you've got. So 0 goes with 8 as per my table. 1 goes with 6, which isn't on my table, so I'm going to write it in. 2 goes with 4, that is correct. You really want to check these as you go along. It kind of helps you realize you've done it right. 3 goes with 2, so I'm going to write that one in. 4 goes with 0, yeah, that one matches. And 5 goes with -2, so I'm going to write that one in. Okay. Once I've got them all in there, I am going to plot the graph underneath. So my first value is 0, 8. 0, 8 goes here. My next value is 1, 6. 1, 6 is there. My next value is 2, 4. 2, 4 is here. And then I've got 3, 2. And then I've got 4, 0. And then finally 5 minus 2 is down here. Okay, and again with my ruler I'm just going to join that all up with a nice straight line through each of those points. Okay, job done. Now this next one says draw the graph of y equals 3x minus 1 for values of x from -1 to 3. Now there's no table here, but it's just pretty easy to make one. So I'm going to draw an x. I'm going to draw a little table. -1 to 3. -1, 0, 1, 2, 3. And then y, and the function is y is equal to 3x minus 1. Now again, I could just use the table function. I can type in the new function and then press draw, and it's going to work them all out for me, or I can work them out for myself. Either way, I'm going to get the answers -4, -1, 2, 5, and 8. Okay, which I can then plot on my graph. So -1, -4 is down here. 0, -1 is here. 1, 2 is there, look. 2, 5 is here. And 3, 8 is up here. Okay. Then once we've got them all drawn, line up my ruler through each of my points. Remember, I don't start and stop on the last point. I go the full length of the graph paper like that. Right, question 52. A line has the equation y equals 3x minus 5. Write down the gradient of the line. Okay? Well, equations of straight lines are normally written in the form y equals mx plus c, where m is the gradient and c is the intercept. So my m, look, is that 3 there, and the c value is that -5 there. Okay? So that tells me that the gradient m is 3 and the y-intercept is -5. Okay? Question 53. Work out the gradient of the straight line through -2, 3 and 1, 9. Okay? Now there's a formula for doing this. You can say that m is equal to y2 minus y1 over x2 minus x1. If you're good at remembering formulas, that's the best way to do it. So this one here is x1, y1, and this one is x2, y2. So subbing those values in, y2, look, y2 is there, look, it's the 9. So 9 minus y1 is that one, that's 3. So 9 minus 3 goes on the top. And then underneath there, I've got x2. x2 is that 1 there. So 1 minus, then x1 is that -2 then. So 1 minus -2. So 9 take away 3 is 6. 1 take away -2 is 3. So I've got 6 divided by 3. So that's 2. So the gradient is 2. Okay. Now, if you don't get on with formula like this, the alternative way to do it would be to quickly sketch a pair of axes like this and plot the points on roughly. Minus 2, 3 would be like 2 to the left and 3 down. It would be minus 2, 3 down there. And 1, 9 would be 1 to the right and 9 up, wouldn't it? It'd be up here. 1, 9. So if you want to work out the gradient of that line, then you just kind of triangulate between them. Okay, and then the distance here on this long side here is going to be the difference between that 9 and that 3. So 9 take away 3 is 6. Okay, and on the other side, the length of the other line is going to be the difference between 1 and minus 2, which is 3. Either way, look, you're doing the same sums as you're doing in this calculation. And then once you've got the 6 and the 3, then the gradient is going to be change in y is 6 divided by change in x 3, which is going to give you 2 as the formula did. Okay, so you either remember the formula or you know how to work it out from like a sketch over there. Okay, I'll give you two methods. Use one of them and you'll get it right. Question 54, a straight line has gradient 6 and passes through the point 319. Work out the equation of the line. Give your answer in the form of y equals mx plus c. Okay, so we've been given the gradient 6, so we already know the m there, it's 6. Okay, so I can say the equation has the form y is equal to 6x plus c. I don't know what the c is just yet, but I do know it passes through the point 319. So if I say it passes through 319, now 3 is the x coordinate and 19 is the y coordinate. So if I sub in 19 for y, so I can say 19 is equal to 6 lots of x, 6 lots of 3 plus c. So I've got 19 equals 6 lots of 3 plus c. 6 threes is 18, so 19 is equal to 18 plus 1. So c is 1 basically, isn't it? c is equal to 1, or taking 18 away from both sides. Either way, c is 1. Okay, so I know the gradient is 6, I know the y-intercept is 1, so therefore the equation of the line is y is equal to 6x plus 1. Question 55, a straight line has a gradient 4 and passes through the point 523. Work out the equation of the line. Again, same thing, I've been given the gradient is 4, so I know that the 4 goes there. So I know it's of the form y is equal to 4x plus c. I just need to work out the value of c now, and I can do that from this coordinate here that they give me, a point that it passes through. So it passes through 523. So subbing those values in for y and x, y is 23. 23 is equal to 4 lots of x, 4 lots of 5 plus c. 4 lots of 5 is 20. So taking 23 away from, 20 away from both sides, I'm going to get c is equal to 3. And then I can complete my my line then. So y is equal to my m value, which was 4 lots of x, plus my c value, which we just worked out to be 3. So y is equal to 4x plus 3. Moving on to quadratic graphs, a lot of the principles are the same as for linear graphs in terms of plotting them and things. For a complicated graph like this, probably a good idea to use the table function on your graph. So we're going to go into table mode again on the calculator. Then we're going to type in the formula for the equation that we've got here, y is equal to x squared minus 5. So I'm going to press the option keys and then I'm going to type in my equation f of x. So f of x is going to be equal to this bit after the equal sign, so I'm going to have to type that in. So x squared minus 5 is the function, okay? And then after I've written the function in, I need to go back in and then add in the range, okay? So I want to know where this table starts, stop, and what it goes up in. Now this table starts at -3, it stops at 3 and goes up in ones. So I'm going to type that in, that it starts at -3, it ends at 3, and it goes up in ones. Okay, and then you can see it's going to complete my table for me. use the values that it gives you just to check that you've typed it in correctly. So I've got -3 going with 4, which is correct. -2 goes with -1. I didn't have that one, so I'm going to write it in. -1 goes with -4, that's correct. 0 goes with -5, I'm going to write that one in. 1 goes with -4, I'm going to write that one in. Just check the last two though. 2 goes with -1, that's correct, and 3 goes with 4, that is correct. Okay, so they all lined up, and I've got my missing ones now. So let's plot those on the graph then. So -3 goes with 4, that is up here. Okay, -2 goes with -1, just dipped under the axes. Then the next one, -1 goes with -4. 0 goes with -5. Then 1 goes with -4. Grid lines are making my eyes go wonky. 2 goes with -1. And 3 goes with 4. Oops. Okay. Right, now this time we've got our points, but we need to join them up with a nice smooth curve going through each of those points that we plotted. Okay. Now you want a nice straight line. You want it, use a nice sharp pencil so it's not too thick. You want one continuous line through each of your, doesn't matter if it wobbles a bit, but what does matter if you have more than one line. Okay, so if you feather, that's no good, and also if you miss one of the points, which I did there, that's no good either. Okay, so that's reasonable. It's a bit thick. I should have used I used a pencil tool rather than the pen tool, so it's a bit thick on mine. But yeah, you use a nice sharp pencil, yours will be a little bit clearer. Then part C says use a graph of y equals x squared minus 5. That's what I drew to write down the values of x when y is 0. Y is 0 is actually the x-axis, isn't it? That's the line y is equal to 0. So where does this graph pass through the x-axis basically? It passes through the x-axis here, at that value, and here. At that value there, then, doesn't it? Then the 2 points. So I just need to write those down. So 1 seems to be at about -2.4, so negative 2.4 on one side, and on the other side it's symmetrical, isn't it? It's going to be 2.4 on the other side. Okay. Right. Again, I'm going to be using the table function to complete this quadratic curve. So I'm going to go into the table mode on my calculator. I'm going to hit the option key and I'm going to enter the function x squared plus 2x into the function f of x. So x squared plus 2x. Okay, that's my function typed in. Next thing I need to do is go back and put the range in that we're going to be using. This time we're going to go from -3 to 1, going up in ones. Okay, that gives me my table of values. Again, just check your values as you go along. -3 goes with 3, that's correct. -2 goes with 0, let's write it in. -1 goes with -1, that's correct. 0 goes with 0, that's correct. 1 goes with 3, let's write that one in. Okay, so once we've got them all written in, then we can plot the points. So -3, 3 is up here. -2, 0 is on the axes there. -1, -1 is just down there. 0, 0, again back on the axes, and 1, 3 back up here again. Okay, so you can see it's a distinctive parabola, quadratic curve. Okay, so the next thing is just to join them up with a nice smooth curve. Okay. Okay, like that. Oh, phew, they've drawn this one for me. So here's the graph of y equals x squared minus 7x plus 10 for the values of x from 0 to 7. Write down the roots of x squared minus 7x plus 10. Now, the roots are just where the graph passes through the x-axis. So it's going to be at that point there, 2, and at that point there, 5. So the roots of this equation are x is equal to 2 and x is equal to 5. Write down the x coordinate of the turning point of the graph. Now, that is going to be this point here in the middle at the bottom of the graph. Okay, now it's going to be halfway between the roots. So 2 plus 5 is 7 divided by 2 is 3.5, or you could just read it off from the graph. Either way, you can see it should be x is equal to 3.5. So x equals 3.5 for that. Question 59, here is a sketch of a curve, y equals x squared minus 4x minus 5. Write down the roots of this graph. Well, again, the roots are where it passes through the x-axis, and they're already marked on the diagram here, aren't they? You've got one there, and you've got one there, and they've already given the values to you. They're minus 1 and 5. You just need to read them off the graph. So x equals minus 1, and x is equal to 5. Part B says work out the coordinates of t, the turning point of the graph. Okay, so the lowest point on the graph, there's different ways you can do this. The x coordinate is going to lie halfway between these two. It's going to be, because the graphs are symmetrical down the middle here, this is like a mirror line, then the distance from here to here is the same as the distance from there to there. So what's halfway between minus 1 and 5? Well, minus 1 plus 5 is minus 4, divided by 2 is 2. Okay, so the x coordinate is going to be 2. And then the y coordinate we could find by subbing x is 2 into the equation. So we could say the y value is 2 squared minus 4 lots of 2 minus 5. Okay, just subbing x is in 2 into the equation and just working out what that is. So what is 2 squared? It's 4. What is minus 4 times 2? It's minus 8. And then minus 5 there. So I've got 4 minus 8 minus 5. And I believe that comes to negative 9. So the y coordinate is going to be negative 9. So it's going to be the coordinates to negative 9. Okay. Now there's another way of doing it. You can also complete the square. So if you don't like doing it that way and you know how to complete the square, you could complete the square. So if I've got y is equal to x squared minus 4x minus 5, we take that coefficient of the x there and we halve it, and we rewrite our quadratic as x minus 2 all squared. We take off a square of the 2, which is 4, and we combine it with the 5. So that's going to give me x minus 2 all squared minus 9. So this bit here, x minus 2, we pick the value of x that makes that bracket equal to 0. That's what gives us the 2 there. And then when x is 2, I get 2 minus 2 is 0. 0 squared is 0. The y value is minus 9. So that value there here is the minus 9 we got there. So that's two different ways of doing it. Either find the midpoint of your roots, okay, and that's your x coordinate, sub it into the equation, find your y coordinate, or complete the square. Two alternative methods. It depends really. If you know how to complete the square, then that's quite a nice way of doing it. Otherwise, the other way. Time for a bit of trigonometry. So we're going to be using SOHCAHTOA in order to work these out, aren't we? So the first thing we're going to do is label the sides, which one's which. Okay, now the longest side is always the hypotenuse. I'm going to label it H. Then here's my angle here. Now this side here is adjacent to the angle. It's next to it. That's why that's the A. And this one over here is the opposite. Okay, so that means we know what the hypotenuse is. It's 8. And we know, well, we want to find the adjacent, which is x. We don't know O. We don't really care about O. Not interested in O. Okay, so if you think about SOHCAHTOA, SOHCAHTOA, which ones have got O in them? Because we don't want the ones with O. SO has got an O in it, so we don't want that one. TOA has got an O in it. We don't want that one. That leaves us that one, doesn't it? The cosine. So we want the cosine in this case. So we're going to write down the cosine formula. Cosine theta is equal to adjacent over hypotenuse. Then we're going to sub in from the diagram. Okay. So the theta is always the angle, isn't it? That's a placeholder for the angle. So cos 60 is equal to the adjacent, which is the thing we want to find. It's x divided by the hypotenuse, which was 8. Okay, so we've got cos 60 equals x over 8. Rearranging, going to just move this 8 over here. Multiplying both sides by 8 has the effect of moving that 8 from there up to there. Look, so I'm going to get 8 cos 60 is equal to x. At this point, we just need to type it into the calculator. So what is 8 cos 60? That comes out to be 4. 4. Question 61. Use trigonometry to find the length x. Again, I'm going to do this in exactly the same way. I'm going to start off by labelling the sides. This is the hypotenuse. This is the opposite. This is the adjacent. Now this time, it's the adjacent I don't care about. I've got the hypotenuse. I want the opposite. The adjacent doesn't figure into my thoughts or plans at all. So SOHCAHTOA, anything that's got an A in it is of no interest to me. So cosine has got an A in it. Tangent has got an A in it. So it's this one, it's the sine that we want in this case. Writing out the formula for sine, sine theta is equal to O op over hype, okay? Subbing in from the diagram, theta is a placeholder for the angle, that's 72. So sine 72, that's equal to the opposite, x divided by the hypotenuse 8. Rearranging, x equals 8 sine 72. Type that into the calculator. 8 sine 72, that comes out to be 7.608. Now, unless it says otherwise, I normally round these off to 3 significant figures. I'm going to round it off after the 0. Next digit's an 8. I'm going to round it up. I'm going to get 7.61. Question 62. Use trigonometry to work out the size of an angle x. Okay, same deal as last time. Label the sides. Hypotenuse, opposite, adjacent. Okay, which one don't we care about? We do not care about h. So which one do we care about? The ones not with h in it. So h in so, h in ka, no h in toa. So writing out the tan ratio, tan theta is equal to op over adj. Sub in for theta, that's the angle. Oh, that's the thing we want to find this time, isn't it? So it's just going to be tan x is equal to the opposite, which is 10, divided by the adjacent, which is 4. So this time, if we want x, we're going to have to use the inverse tangent, aren't we? So x is equal to tan to the minus 1 of 10 over 4. So you're going to type that carefully in the calculator. You're going to have to press the shift key, shift tan, and then 10 over 4. That comes out to be 68.2 to the nearest decimal point, then, isn't it? So 68.2. Question 63. Here's a right angled triangle. Use trigonometry to work out the size of angle x. Okay, same old, same old. Label the sides. H, that's O, that's A. So which one don't we know? We don't know A. Don't care about A. So SOHCAHTOA. Which one has got an A in it? Toa does. Ka has. Soh doesn't. Okay, so it's sine. Sine theta is equal to op over hype. Sub it in from the diagram. Opposite is 13. Hype is 16. Theta is our angle. In this case, it's x. So I've got sine x is 13 over 16. So x then is the inverse sine of 13/16. Okay, so I'm just going to type that into the calculator. Shift sine 13 over 16. What's that then? That's 54.3 to the nearest decimal point. Next up, quadratic expressions and equations. So 64, solve x squared equals 30.25. Okay, so if I want x, I'm going to have to root both sides, aren't I? So x is going to be the square root of 30.25. So what is the square root of 30.25? 30.25 square rooted, that's 11 over 2, or 5.5. Okay, so then x is going to be equal to plus or minus 5.5, because both negative 5.5 squared is positive 30.25 and positive 5.5 squared is as well. It's always two answers when you square root an answer like that. 65, when x squared equals 16, the only value that x can be is 4. Is this true or false? Well, I've just explained that. It's false, because it's x is going to be equal to plus or minus 4, so there are two solutions. Okay, there are two solutions, not one. Question 66, multiply out and simplify x minus 8 all squared. Okay, when you square something, you multiply it by itself, don't you? So that's going to be x minus 8 times x minus 8, okay? Now, when you're multiplying out brackets like this, I recommend that you use a grid. So I'm going to have x minus 8 along there, and I'm going to have x minus 8 down here. X times x is x squared, x times minus 8 is minus 8x, x times minus 8 is minus 8x, and minus 8 times minus 8, that is positive 64. Okay? Now in my grid, I've got three types of things. I've got a term in x squared, so that goes at the beginning, x squared. I've got two terms in x. I've got minus 8x and minus 8x. Add those together, that is minus 16x, minus 16x. And then finally, I've got the 64 in the end, plus 64. And that are that's my expanded form there. X squared minus 16x plus 64. Question 67, expand and simplify y plus 8, y minus 3. Again, I recommend doing this as a grid. People try and do it with like these things, and often they miss bits out and get it wrong in the test. So I just think it's good practice to do the grid because it's got a place for every value that you need. So I've got y and 8 and y and minus 3. Y times y is y squared. Y times 8 is 8y. Y times minus 3 is minus 3y. 8 times minus 3, that's minus 24. So I have got a term in x squared, or y squared here, that's y squared. I've got an 8y and a minus 3y. Now 8y take away 3y, that's 5y. And I've got a minus 24. That goes on the end. Minus 24. Okay, good job. Question 68a, expand and simplify x plus 6, x minus 3. Again, I'm going to do it as a grid. I'm going to say x plus 6 and x minus 3. X times x is x squared. X times 6 is 6x. X times minus 3 is minus 3x. Minus 3 times 6, that's minus 18. I have got a term in x squared. X squared. I have got two terms in x. I've got 6x minus 3x. That gives me 3x. And I have got minus 18. Okay. B, solve x minus 9, x plus 4 is equal to 0. Okay, now when you've got two things multiplied together give you 0, either one thing is equal to 0 or the other thing is going to be equal to 0. Now if x minus 9 is equal to 0, then x must be equal to 9. If x plus 4 is equal to 0, then x must be equal to minus 4. So x is going to be 9 or x is going to be minus 4. 69a, expand and simplify x plus 5, x minus 4. I'm going to do that as a grid. I'm going to have x and 5 and x and minus 4. X times x is x squared. X times 5 is 5x. X times minus 4 is minus 4x. 5 times minus 4 is minus 20. What have I got? I've got a term in x squared. X squared. I've got two terms in x. 5x minus 4x, that's x. I've got a term minus 20 on the end. Minus 20. B. Solve x minus 8, x plus 7 is equal to 0. Got two brackets multiplied together and I get 0. That means one of them must be 0 or the other thing must be 0. Now if x minus 8 is 0, then x was 8. If x plus 7 is 0, then x was minus 7. Okay, so my answer is x is 8 or x is minus 7. Question 70, part A, need to factorize x squared minus 9x plus 20. Now if this factorizes, it's going to factorize into two brackets. Now the number on the end, 20, that has factor pairs of 1 and 20, 2 and 10, 4 and 5. They're all the factor pairs of 20. Now I want a pair of numbers that when you add them together, it gives you negative 9. Okay, now notice that that is positive and that is negative, so if they add together to give you negative 9, then they both must be negative numbers to start with, and they must multiply together to give you 20, and they must add together to give you negative 9. So I'm thinking it's this pair here, but with minus signs in front of them, so it must be x minus 4, x minus 5. So the minus 4 times the minus 5 is plus 20, and the negative 4 plus the negative 5 is negative 9 when you multiply it out. Okay. Next one, x squared minus 9x plus 20 is 0. Notice that's the same thing. So I can say, well then, x minus 4, x minus 5 must be equal to 0 because it's the same thing as we just had. And if x minus 4 is equal to 0, then x is 4. And if x minus 5 is equal to 0, then x is 5. So my answer is x equals 4, x equals 5. Question 71, factorize x squared minus 100. Now I notice this is the difference of two squares. It comes up a lot, you need to recognize it. I've got a square, x squared. I've got another square, 100, which is 10 squared. I am subtracting them from each other. In maths, that's the difference, which is why it's called the difference of two squares. So these always factorize. So you square root the first one, x squared square root is x. I'm going to have x at the front there and there. I'm going to square root 100, I get 10. I'm going to get 10 at the back there and there. I'm going to have 1 plus, 1 minus. That's what it looks like, x plus 10, x minus 10. If you don't believe me, multiply it out. You'll find it factorized. It simplifies down to that x squared minus 100. We're on to the last section, which is a great job because my voice is about to go. It's getting croakier and croakier. We're on to tree diagrams, question 72. And the ordinary fair dice is rolled. Complete the tree diagram for the dice landing on 4. Okay, so either lands on 4 or it doesn't land on 4. The probability it lands on 4 is 1 over 6. So the probability it doesn't land on 4 is 1 minus 1 over 6. That must be 5 over 6 there. On the second spin, does the probability change? No, every time you roll it, you're going to get the same chance of rolling the 4 or not rolling a 4. It doesn't matter if you rolled a 4 the first time or not, it's going to be the same down here as well. Okay, so you're going to get 1, 6, 5, 6, 1, 6, 5, 6, 1, 6, 5, 6. And part B says, work out the probability of the dice landing on 4 both times. So 4 both times is this row and this row. Probability of 4 and 4. Now in maths, and in probability, and means multiply. So it's going to be the probability of getting 4 on the first roll multiplied by probability of getting 4 on the second roll. So the probability of getting 4 on the first roll is 1/6. Probability of getting 4 on the second roll is 1/6. You multiply that together, you're getting 1 over 36, aren't you? That's my answer, 1/36. Question 73, 2 ordinary fair dice are rolled. Complete the tree diagram. So the probability that you get less than 3, that's 1 in 3. What outcomes are less than 3? Less than 3 is 1 or 2, so you've got 2 outcomes out of 6, which reduces to 1 over 3. So probability if you get 3 or more, you get 3, 4, 5 or 6, that's 4 out of 6, which simplifies to 2 out of 3. So that's 2 out of 3 there. It doesn't matter on the first or second roll, you're not going to change your probability of rolling a particular score on the dice. It should be the same each time. So that's 2/3 there as well, and 1/3 and 2/3 there as well. Okay, work out the probability that both dice land on the number less than 3. So which root is that? That's less than 3 and less than 3. So what's that going to be? Probability of less than 3 and less than 3. In probability, and means multiply. So we're going to do the probability of 1/3 times the probability of 1/3, and that is going to be the probability, well, that's 1/9 then, isn't it? Okay, 1/9. Question 74, Jose and Maria each take a test. The probability that Jose passes is 0.8 and the probability that Maria passes is 0.4. Complete the tree diagram. I've got Jose on 0.8 chance of success. So the probability it doesn't pass is going to be the rest out of 1, isn't it? 1 minus 0.8 is 0.2. Maria's got a chance of 0.4 of passing, so not passing is going to be the rest. It's going to be 0.6. These two numbers should add up to 1, and it's going to be repeated down here. Jose passing is not going to influence if Maria passes or fails. They're independent of each other. So work out the probability that they both pass. So the probability of pass, the probability of pass and pass is going to be the 0.8 probability of Jose passing times the 0.4 chance of Maria passing. So what is 0.8 times 0.4? That comes out to be 8 over 25, or as a decimal, 0.32. 0.32. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.